Hi, my name is Philip Bello. I'm a Senior Product Manager here at Enritsu Company. Today we're going to have another video following up the one that we just did on different building materials, testing them in the field with the Microwave Sightmaster SA20E. But the focus of today's video is going to be mainly on the detrimental effects that water has in the environment. And I'm sure you've heard of the term rain fade. So we're going to demonstrate a little bit of what rain fade does to the signals at the FR2 frequency bands for 5G. In this example, we're at the same frequencies as the last video. We're 27.5 gigahertz to 28.5 gigahertz. However, the Microwave Sightmaster can support all the way up to 40 gigahertz, so you can cover any of the current bands that are being deployed in 5G millimeter wave. So let's get started. What we're going to do here is we're going to start simulating a pretty heavy downpour of rain. I'm going to pour this rain through between the antennas, and we're going to see what effect that it has on the signal itself. Let's get started. So looking at the analyzer while that was happening, we probably had 2 or 3 dB of loss, which may not seem like a lot. However, you have to keep in mind that the amount of rain that was passing between the antennas was only about 6 to 7 inches, or say 15 to 20 centimeters in terms of the width of it. So if you multiply that by the distance when it's outdoors and it's raining from where the base station is to where the UE is that has to receive the signal, that can be many, many times more. So the cumulative effect of all that rain will bring that signal level significantly lower than what we saw just with that small little piece. So the next thing we're going to do is we're going to test some cloth type materials that may be used for concealing antennas or concealing 5G base stations, which is a big issue today. And so what I have in my hands is a piece of very strong canvas material, which could be something that we use because of its flexibility and it's easy to work with. So let's just see what it does. So we put one layer of the canvas between, and it literally has no effect on the signal, which is good news, which might make it attractive for use. I fold this sample in half, and now we have 2 layers, and again, no impact whatsoever. And then I'll fold it in half one more time, so it's 4 layers thick, and still no effect on the signal. But what happens if this was wet? Let's do that experiment. So I've taken that same sample, it's a little wet still, we just wring it out a little more. So the same piece of material which had no attenuation on the signal when it was dry, we now have 10 dB of attenuation just because it's absorbed some moisture, it's wet. And if I fold it in half, that number increases to greater than 20. And if I fold it in 4, we're greater than 40 dB of loss. So the takeaway from this is if you're going to use a fabric type material to conceal antennas or base stations, you absolutely must apply some kind of waterproofing or pick a material that's waterproof so that it cannot absorb any moisture. We'll test another material that we tested in the first video, and this is the piece of foam which had absolutely no loss when it went through when it was dry. We'll get this wet and see what happens. Now I've wrung out most of the moisture, and again, here we have 20 dB of loss. Where it's dry, there's nothing. Where it's damp, there's 20 dB of loss. So again, water, moisture is a real detrimental to the actual signal quality. And the last we'll do is we have our thermal pane window that we created for the first video, which really has no loss. What I'm going to do now is I'm going to hold it at a bit of an angle, and I'm going to pour the water on it so that the water would sheet, so that would represent a strong storm with wind blowing the water against the glass. And we're going to see what happens in that case. Again, we're ranging from 10 to 20 dB of loss. because of that little bit of water that's been sheeting on the glass. And you can see that we still have about 4 or 5 dB of loss, whereas when it was dry it was less than that. So that's pretty much the conclusion of what this video was intended to do, just showing how water has a real detrimental impact on the signal quality. For more information, please visit www.enritza.com. There's an application note specifically showing how you can set the SA20E up. It also describes the accessories that were used, so that if you want to replicate this for yourself, all that information will be in the app note. The app note will also have a table of various materials that were measured, so you can get an idea of what works and what doesn't. Thanks for watching.